Welcome back, focused learners, to another explainer. Look, today we are tackling an absolute monster of a topic, but we're going to do it in the most structured, logical way possible. We're looking at the massive explosion of artificial intelligence education. If you've tried to learn AI lately, you know exactly what I mean. You've probably felt completely overwhelmed by just figuring out where to start. But what if I told you there's actually a hidden architecture behind all that noise? Today, our goal is to decode the logic behind the world's absolute top AI courses. We aren't just going to look at what they teach, but crucially, why they teach it in a very specific order.
Okay, let's dive into this. We've curated a landscape of 12 of the most popular, highly rated AI courses available right now. We're talking instructors from Stanford and Harvard, researchers at Google, the folks at FastAI, the heavy hitters. But I don't want you to look at this as just some list of courses. I want you to view this as an architectural blueprint. Every single one of these programs follows a highly specific sequence of learning. They are constructed step by step, and understanding that underlying logic, that's the ultimate hack to mastering AI yourself.
So here is our syllabus for today's explainer. We're going to cover 1. Demystifying AI learning paths. 2. Building the ML foundation. 3. The deep learning scaffold. 4. Gen AI and the LLM sequence. 5. Taking AI to production. And finally, 6. Choosing your next step. We're literally following a logical progression from the ground floor all the way up to the penthouse of AI.
Let's kick things off with Section 1, Demystifying AI Learning Paths, Deconstructing the Architecture.
When you look at all these top courses, the sheer volume of advanced terminology is enough to make your head spin, right? But the secret to efficient learning is realizing that the sequence of the material is just as important as the material itself. It's like building a house. You literally cannot build a roof without walls, and you definitely can't train a custom chatbot if you don't know how a basic algorithm actually learns. If we zoom out and look at the underlying logic of almost all 12 of these top courses, they map onto 4 essential, entirely unskippable cognitive steps. You start with the foundations. That's the basic math and logic of how machines learn. Then you move into deep learning, which introduces artificial neural networks. Once that scaffold is firmly built, you step into generative AI. That's where things like ChatGPT live. And finally, you take all of that and move to production, making it actually work in the real world. You just can't skip ahead without your whole knowledge structure collapsing.
That brings us to Section 2, Building the ML Foundation, the ground floor.
This is where the most fundamental, traditional learning logic begins. It's all about teaching your brain to think the way a machine processes data. And this brilliantly illustrates that classical approach, Andrew Ng's legendary machine learning specialization. It's historically the most watched ML course in the world, and for good reason. Look at the strict order here. ML basics, then regression, then classification, and then clustering. Why that exact sequence? Well, logically, you absolutely have to start by predicting a continuous number. That's regression, like predicting the price of a house. Once you grasp that concept, you can logically move to classification, predicting categories, like whether an email is spam or not. Only after mastering those supervised tasks do you tackle clustering, which is finding hidden patterns in completely unlabeled data. The cognitive progression there is just flawless.
But contrast that with Harvard's CS50 AI course. Their logic is entirely different, though equally structural. They use a bottom-up logic that starts with search, literally how an AI navigates a maze or plays tic-tac-toe. Then it moves to knowledge, which is how an AI represents information, then learning, and only at the very, very end do they even touch neural networks. Harvard's philosophy is pretty clear. You must logically grasp classical AI decision-making before you're allowed to play with the black box of modern neural nets.
All right, Section 3, the deep learning scaffold, scaling up.
Now, what's really interesting about this is how things change once that foundation is poured. We start adding heavy layers of complexity, and this is where the logic paths really branch out depending on your specific goal. Notice the stark contrast in learning styles here. Look at Harvard's traditional, methodical approach on the top. Search to knowledge to learning to neural nets. It's built for deep, rigorous academic understanding. But look at Milobin's wildly popular GitHub LLM course on the bottom. It's a fast-tracked pipeline. The logic skips classical ML entirely and jumps straight to LLM basics, then fine-tuning, deployment, and optimization. The logic here isn't about understanding a tic-tac-toe algorithm. It's pure engineering logic designed to get you deploying large language models as fast as humanly possible.
Then you have Fast.ai, which completely flips the traditional logic right on its head. Instead of bottom-up, they use a top-down logic. You start with a highly practical approach, writing code and running real-world projects immediately. I mean, you build an image classifier in the very first lesson. It's a highly successful cognitive trick.
It's almost like giving you dessert first to fuel the really tough theoretical broccoli that researchers at Google and OpenAI rely on later. So, okay, we've got our foundation and we've built our deep learning scaffold. But this brings up a massive question for anyone studying this field right now. How exactly do we logically cross the chasm from those foundational, basic neural nets all the way to a cutting-edge generative AI like ChatGPT? It feels like an absolutely massive leap, doesn't it?
That takes us to Section 4, Gen AI and the LLM sequence, the penthouse.
This is easily the most requested topic in tech today, for sure, but you simply cannot survive in the penthouse if you haven't built the floors beneath it. So, the crucial point is perfectly captured here in Andrej Karpathy's Neural Nets Zero to Hero course. Keep in mind, Karpathy was a founding member of OpenAI, and his logical sequence is rigid. Step 1, neural nets. Step 2, transformers. Step 3, GPT from scratch. You literally cannot build a generative pre-trained transformer, a GPT, without first mastering the transformer architecture that actually powers it. The logic dictates that complex AI is really just simpler neural components stacked in incredibly clever ways.
But what if you don't want to build one from scratch? What if you just want to use these models effectively? Well, DeepLearning.ai offers a series of short courses that follow this beautiful logic of interaction. It evolves step by step. First, you learn to just talk to the AI, which is prompt engineering. Then you learn to give the AI your own private data, which is RAG, or Retrieval Augmented Generation. Next, you give the AI tools so it can take action. Those are agents. And finally, you change the AI's core behavior by fine-tuning it. The logic flows so naturally from simply conversing with a frozen model to completely rewiring its brain.
We see a very similar logic over in Microsoft's Generative AI for Beginners course. They also progress right through RAG and agents, but their end goal logic is slightly different. Instead of focusing on fine-tuning the model's brain, their sequence drives you toward deployment and apps. The logic here is inherently practical, right? An agent is really just a script on your computer until you wrap it up in an application and actually deploy it for a user to interact with.
Let's move to and see how this builds in Section 5, taking AI to production, from sandbox to real world.
Because it's one thing to have a really cool AI model running in a little sandbox on your laptop, it is an entirely different logical beast to make that AI work reliably, safely, and cost-effectively out there in the wild. The full-stack deep learning course taught by Berkeley researchers zeroes right in on this specific challenge. Just look at their sequence: data, model, deploy, production. The incredible insight here is that the model is only step 2. The logic they impart is that the fanciest AI model in the world is absolutely useless without the rigorous initial step of data preparation and then all the subsequent logistical hurdles of deploying and actually maintaining it in production. It completely shifts your mindset from being an AI researcher to being an AI engineer.
Let's wrap it up with Section 6, choosing your next step, your own blueprint.
So we've decoded the logic of the world's best courses: bottom-up, top-down, engineering fast tracks, and rigorous academic sequences. Now it's about applying this architectural blueprint to you. Because hey, maybe you don't even want to be an engineer at all. If you're a non-technical business professional, your required sequence looks more like Andrew Ng's AI for Everyone. Notice the complete absence of code in this flow. The logic steps from AI basics directly into business applications, then high-level strategy, and finally analyzing AI impact. It bypasses Python and neural net math entirely because the logic of a business leader dictates they need to understand what the technology can do, not how to code it from scratch. And that brings us to the core realization of this entire explainer. When you look at that massive landscape of AI education out there, it's so easy to panic. But the secret to mastering AI isn't learning every single framework, or every brand new model, or every coding language. It is simply learning the right things in the exact right logical order. Trust the blueprint. Let the logical sequences designed by these world-class experts do the heavy lifting for your brain. So, we've laid out the architecture. You've seen the ground floor foundations, the deep learning scaffolds, the generative AI penthouse, and the path to real-world production. You understand the why behind the what. The only question left is this. Now that you have the blueprint in your hands, which logical step will you take first? Thanks for joining me on this explainer. Focus, learners. Get out there and start building.